Today's question is, how many nice polyhedra are there? And first, we should define nice as a one type of side. Each side is a regular polygon, and polyhedra as a 3D polygon. So first, before we begin, we have to first look at what a net is. So if this is a cube, this is a net. So if you pretty much unfold the cube shape. And then we have to notice what a vertex is. And so the vertex is where these sides intersect. So here would be 2 points, here would be 2 points, as well as these, because these two sides are connected. So looking at this net, here's a vertex. And if you would fold this over, it would fold onto itself. And so this leads us to go to the rule that at least 3 sides at a vertex is what's needed for a nice polyhedra. Then, so let's say we have this, okay? We have at least 3 meeting at the vertex, but if we would fold this onto each other, it would just like crumple up and you wouldn't even be able to do it. So this leads us to do rule number 2, which is the sum of the angles is less than 360. So the sum of these angles all around have to be less than 360. So looking at these two rules, which is less than 3 sides, or at least 3 sides, we'll make the at least mark because we know that we can have 3 sides. So at least 3 sides or more at the vertex, and then it's less than 360 as the sum of the angles. And to find the sum of the angles, we can use this equation which we had used before. 180 degrees times n minus 360 all over n, or the number of sides. So looking at an equilateral triangle, we have 3 meeting at the vertex. Using this equation, we'd have each of the sums as 180. For 4, 240. For 5, 300. And for 6, we'd have 360. So actually this one wouldn't apply. So our nice polyhedra are these 3. Then looking at squares, for a 3 at each vertex would be 240, so that would work. But 4 would be 360. So only this one would work. Moving on to a pentagon, 3, but we have 360, so that one would not even work. This one, it actually, at 3 meeting at each vertex, it would be more than 360, so that wouldn't work either. And we know this because, according to our equation up here, the bigger n gets, the smaller 360 over n gets, and the larger the sum of the angles. And so that's why we see that trend. And so really, our nice polyhedra can be seen right here.